Okay, today too, we want to look at the application of differentiation. The application of differentiation. And with the application of differentiation, there are a lot of things you'll be looking at. One, the gradient function. You can apply differentiation in finding the gradient function. That is the gradient at on a curve, but the gradient of a point at any point on the curve, the gradient at any point on a curve. You can apply differentiation to find that particular gradient. Again, too, you can use the application of differentiation to find the tangent and normal to a curve. So the tangent and normal to a curve. You can also use it to find the rate of change. The rate of change, either in small changes and many more. But with this particular video, we want to look at the gradient function, how to apply differentiation in the gradient function. Now, when you say a gradient of a curve, the gradient of a curve at any point xy, the gradient of a curve at any point xy is obtained by substituting the values of x and y into the expression for dy dx. Into the expression for dy, and know that the expression dy dx simply means the derivative of the y with respect to the derivative of the x. So now this is the same as the gradient of the tangent at any point. Anytime that you find the gradient of a curve, it's the same as the gradient of the tangent at any point. So for instance, if I have this as my curve, on this curve lies within the Cartesian plane. Now, if I want to find the gradient at this very point, so now let's say this curve is y is equal to x squared. Y is equal to x squared. Now the gradient at each point on the curve is known as, which is given as m, or we always represent gradient as m, to be the same as the expression to which we get for dy dx. So now if you have a function, let's say y is equal to x squared, and you have to find the gradient at a particular point, let's say this is point P, and this point P is having coordinate y, and this point P is having coordinate x, so x, y. So the coordinates are the x, y. And you are asked to find the gradient at this particular point on this curve. It is the same as finding the gradient of the tangent that touches the point on the curve. So you know that when you have a curve and a straight line that touches the curve at a particular point, that line is known as what? The tangent to the curve. So any straight line that touches a curve at a particular point is known as what? The tangent to that very curve. So if we have to find the gradient at a certain point on the curve, it's the same as drawing a line that touches that particular point on the curve and find the gradient of that line. And that is simple as what? Y dx. So for instance, if this curve is y is equal to x squared, and I have to find the gradient of this curve, it's simply what? Y dx, which is equal to what? 2x. Now when you get the 2x over here, and you know the point x, y, y1, you can find the gradient of this line, because we said every straight line has this equation y is equal to ax plus b. So if a straight line has this equation and the straight line is represented this way, then the gradient of this curve now becomes what? A, because that is the coefficient of the x. So that is the gradient of this one is A, and this is the same line that is starting here. So let's say the line here, the straight line here is y is equal to ax plus b. And then the curve, which is y is equal to x squared. Then the gradient to find the 2x is the same as the gradient of this tangent m, and that will give what? A. So therefore you can say your 2x is equal to A. So imagine this was a number. Let's say y is equal to 5x plus 6. Then your gradient will be 5, so 2x should be equal to 5, and you can find your x as what? 5 on 2, which will be the coordinate here, 5 on 2. Now after finding the x, you can put this x value over here to find what? Your y value. So y then become 5 on 2 all square, which is what? 25 on 10. And y value here becomes 25 on 10. And that is how you find the coordinates. Okay, let's take a typical example and let's look at how we can go about that. Now the example says that you should find the gradient of the curve. Find the gradient of the curve y is equal to x cubed minus 3x squared plus 2x minus 6 at the point where x is equal to 1. At the point where x is equal to 1. So now they've given us that we should find the gradient of this very curve. Are you getting it? So now our solution, our curve is what? X is equal to x, y is equal to x cubed minus 3x squared plus 2x minus 6. And we say the gradient of the curve is the same as what? The same as the gradient of the tangent at that point. What is the point here? The point here is what? X is equal to what? 1. So therefore, if the point here is x is equal to 1, you can find the gradient over here to find you can find the gradient of the curve over here. So now if x is equal to 1, then you say gradient is what? Putting in the values for x and y into the expression for the y is equal to what? The x. Now the y dx, that derivative of this function becomes what? 3x squared minus 6x plus 2 minus 0. Anytime find the derivative of a constant is 0. Okay, so now since the y dx is equal to this, then where x is equal to 1, so wherever you see x over here, we can put the 1 there to find the gradient. So therefore the x is equal to 1 squared minus 6 times 1 plus 2. And when you do this, you get 5 minus 6. So therefore, our dy dx is equal to what? Negative 1. Okay. Let's take another example. Example 2. And let's see what we can do. So find the values of x for which the gradient function of the curve is 0. So now this is another question, and you have to find the values of the x for which the gradient function of the curve is 0. And this is the function y is equal to 1 on 4 x exponent 4 plus 2 on 3 x cubed minus half x squared minus 2x plus 1. And this is the function itself. We are asked to find the values of x for which the gradient of the function curve is 0. Okay. So solution, what do we do here? It's very simple. We just have to find the derivative, the dy dx. So this is a function, so the derivative of the y with respect to the x becomes 4 times this, 3 minus that. So that gives 4, half 4 minus 1. I hope you know the differentiation rules already, the general rules for differentiation. So you just apply that and do that. So let me just do that straight. So this one will give you what? X cubed. And this one will give you 3 times 3, which you take this away. This will go to 2. So you get 2x squared minus, when this 2 multiplied by half, which you take it away, so you get what? Minus x minus 2 plus 0. Okay. So when you do your derivative very well, it's 10 by 10. This is what you get. And now the person says that find the function for which the gradient function of the curve is equal to 0. So this is the gradient function. So the gradient function is what? Dy dx should be equal to 0. And you have to find the values of x. So therefore, if dy dx is equal to 0, you have x cubed 2x squared minus x minus 2 should be equal to 0. And now this is a polynomial. So you have to find the factors of the constant here 2. And the factors of the constant here 2 is what? Plus the negative 1 and plus the negative what? 2. So this is the constant, this one. So now you have to put each of the constants into words. Any of them that gives you the answer 0 is a factor of this very equation. So you just put plus 1 into this. So you get to do the function f of 1 into that. If you put the f of 1 into that and you get 0, it means it's a factor. If you put negative 1 and you get 0, it's a factor. Positive 1 and you get 0 is a factor. Positive 2 and negative 2 and you get 0 is a factor. But when you are done with it, you're getting only 3 factors. And the factors you're getting is that x plus 2 multiplying x minus 1 and x plus 1 should be equal to 0. So therefore the factors are x is equal to negative 2, negative 1, or 1. And this becomes the factors of the equation. So for instance, that means when you put x is negative 2 here, you get 0. When you put x is negative 1 in it, you get 0. And if you put 1, x is equal to 1, you also get 0 for this equation. How to try your hands on this last question? Find the gradient of, try your hands on this one, find the gradient of x squared on 25 plus y squared on 4 is equal to 1. At point 3 and 8 on 5. At point 3 and 8 on 5. So you can pause the video, you try hands on it, and you come back for the answer. Okay, so now this is the gradient. So the solution here, we have x squared on 25 plus y squared on 4 is equal to 1. So the LCM is 100. So let's just multiply it so that we get a linear thing. So you get here, multiply it by 100, you are getting 4x squared here plus 20y squared is equal to what? 100. Now this is an implicit function in 2 variables. An implicit function in 2 variables, and we've done that already. So you can go and look at that video, you understand it to come and do this. So now you differentiate this with respect to x, you'll be getting 8x. Plus, when you differentiate this with respect to the y implicit function, you get 3 times 20, which is 40, y, 2 minus 1, dy what? The x is equal to 1. Differentiate the constant, you get 0. So here you make your dy dx the subject, it becomes the gradient of the function. So making dy dx the subject, you get dy dx is equal to negative 8x all divided by what? 40y. Okay. So now what happens is that it says you should find a gradient at this point. So that means your x is equal to 3 or y is equal to 8 on 5. So you put the x value and the y value there. So you get dy dx is equal to negative 8 times 3 divided by 40 times 8 on 5. So 5 goes here 1, 5 goes here 8. This 8 can take this 8 away. So in short, you're getting your dy dx at negative 3 on 8. And this becomes your gradient of this particular function. Sorry, so it's negative 3 on 8. Thank you very much for joining.